Hello, welcome back to my channel. Today we are diving into the magic of prime factorization to find the highest common factor and the lowest common multiples. Two essential concepts in mathematics. Let's get started. Firstly, what are prime numbers? Prime numbers are numbers that have exactly two factors, 1 and themselves. This means that they can only be divided by 1 and themselves. Examples: 2, 3, 5, 7, 11, 13, 17, 19, 23, and so on. Now, what is prime factorization? Prime factorization is the process of breaking down a number into its prime factors. Example: express 60 as a product of its prime factors. It simply means break down 60 using only prime numbers that can divide 60. Let's get started. So if I write down 60, I can do this by drawing a line. Now, what is the smallest prime number that can divide 60? That's just simply 2, because 60 is an even number, so 2 can divide 60. 60 divided by 2 is 30. What can divide 30? 2 is 2 also. 30 divided by 2 is 15. Now, what prime number can divide 15? 3. 15 divided by 3 is 5. Now, 5 is already a prime number, so the only number that can divide 5 is 5. 5 divided by 5 is 1. So, to express 60 as a product of prime factors is just simply 2 times 2 times 3 times 5. Now, we can even go further and write this in index form as 2 raised to the power of 2, because there are two 2's here, multiplied by 3. Since it's just 1 3, it doesn't require any power, then times 5. So, I have just expressed 60 as a product of prime factors. Now, let's go into using them to find HCF and LCM. So, finding HCF. To find the HCF of a set of numbers, identify prime numbers that can divide all the numbers at the same time. So for us to be able to do this, you have to be able to use prime numbers to divide those numbers at the same time. For example, find the HCF of 36 and 48. So this time I'm going to write down 36, draw a line, then write down 48. Now, how do you do this? You simply look for a prime number that can divide 36 and 48 at the same time. In this case, we're going to use 2 because the both numbers are even numbers, so definitely 2 can divide the both of them. 36 divided by 2, that's 18. 48 divided by 2, that's 24. What other prime number can divide 18 and 24? I can still use 2 because 2 can divide the both of them at the same time. 18 divided by 2, that's 9. 24 divided by 2, that's 12. Now, 2 cannot divide 9 and 12 at the same time. So I won't use 2 any longer. I'll just use 3 this time because 3 can divide the both of them at the same time. 9 divided by 3 is 3. 12 divided by 3 is 4. So I have 3 and 4. No other prime number can divide 3 and 4 at the same time. So I'll just stop there. It means that my highest common factor is 2 multiplied by 2 multiplied by 3. If I want to leave my answer in index form, that's just basically 2 raised to the power of 2 multiplied by 3. Or if I want to get an actual answer, it will be 2 times 2, 4. 4 times 3 is 12. So you can either leave your answer in this form or in this form. Let's take another example. Find the HCF of 108, 128, and 144. So I'm going to draw my lines. Then look for a prime number that can divide all of them at the same time. I'll use 2 because they are all even numbers. So 2 can definitely divide all of them. 108 divided by 2, that's 54. 128 divided by 2, that's 64. 144 divided by 2, that's 72. 2 can still divide all the numbers at the same time. 54 divided by 2, That's simply 27. 64 divided by 2, that's 32. 72 divided by 2, that's 36. What can divide all of them at the same time again? Can 3 divide all the numbers? 3 can only divide 27 and 36, but it cannot divide 32. So can 4, no, 4 is not a prime number, so I'll go to 5. 5 cannot divide them. 7 cannot divide them. 9 is not a prime number. 10 is not a prime number. 11 is not a prime number. 11 is a prime number, but it cannot divide all the numbers. So apparently, no other prime number can divide all of these numbers at the same time. So the answer to that question, my HCF will just be equal to 2 multiplied by 2, which is simply 2 squared, or 4. So that's how to use prime factorization to find highest common factor. It's one of the easiest methods to use to find highest common factor. Now, let's use it to find lowest common multiple. To find the lowest common multiple of a set of numbers, identify the prime numbers that can either divide one of the numbers or all of the numbers at the same time until you get to 1. For example, find the LCM of 36 and 44. So in this case, I'll look for a prime number that can divide, if not the both of them, it could be one of them. Let's start with the smallest prime number, 2. 2 can divide both of them actually. 36 divided by 2, that's 18. 44 divided by 2, that's 22. 2 can still divide them. 18 divided by 2, that's 9. 22 divided by 2, that's 11. The next prime number is 3, and 3 can divide 9. So I'll use 3. 9 divided by 3 is 3. But 11 divided by 3 will have a remainder of 2. So because there will be a remainder, don't bother dividing. Just bring down the 11. 3 can still divide 3. 3 divided by 3 is 1. 11 divided by 3 will still have a remainder of 2. So don't bother dividing. Just bring down the 11 again. Now, I have 1 here and I have 11. So 1 is already, the first number is already at the end. So let's go to the second number. What can I use to divide 11? 11 is a prime number, so only 11 can divide it. I'll bring down this 1, and 11 divided by 11 is 1. So you keep dividing until you have 1 on both sides, which we have done. So my LCM will simply be 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 11. If I want to leave my answer in index form, the LCM is 2 raised to the power of 2 multiplied by 3 raised to the power of 2 multiplied by 11, which is equal to 2 times 2 is 4, 4 times 9 is 36, and 36 times 11 will simply be 396. So I have 396 as the LCM of those three numbers. Let's take another example. Find the LCM of 16, 18, and 20. So 16, 18, and 20. What prime number can divide any of them? 2 obviously can divide all of them. So 16 divided by 2 is 8. 18 divided by 2 is 9. 20 divided by 2 is 10. 2 can still divide 8. So 8 divided by 2 is 4. 9 divided by 2, we have a remainder of 1. So you don't need to divide, just bring down your 9. 10 divided by 2 is 5. Now, I can still divide by 2. 4 divided by 2 is 2. 9 divided by 2, we have a remainder, so I'll bring down my 9. 5 divided by 2, we have a remainder of 1, so I'll bring down my 5. 2 can still divide 2. 2 divided by 2 is 1. 9 divided by 2, we have a remainder, so I'll still bring down my 9. 5 divided by 2, we have a remainder, so I'll still bring down my 5. I can still use 3 to divide 9, so 1 will just come down. 9 divided by 3 is 3. 5 divided by 3, we have a remainder of 2, so I'll bring down my 5. I can still use 3 to divide again, so 1. 3 divided by 3 is 1, and I'll bring down my 5. Then 5 will finally divide 5, so 1, 1, and 5 divided by 5 is 1. So my LCM will simply be 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 5, which equal to, in index form, that will be 2 raised to the power of 4 multiplied by 3 raised to the power of 2 multiplied by 5. So my final answer is 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 9, I'll quickly do my multiplication, 16 times 9, that's 54, and that's 144. Then multiply by 5 again, that's 20, that's 22, and that's 7. So my LCM of those three numbers will simply be 720. Alright, let's have a quick recap. Firstly, to find the HCF of a set of numbers, identify prime numbers that can divide all the numbers at the same time. Take note, when it can no longer divide at the same time, you stop there. But when it comes to LCM, to find the LCM of a set of numbers, identify the prime numbers that can either divide one or all the numbers at the same time until you get to 1. So LCM will always get to 1, but HCF stops wherever it can no longer divide the both of them at the same time. Here are a few questions for you to try. Don't forget to like, subscribe, and hit the bell icon for more math tips. Until next time, stay curious and keep solving. Bye for now.